Okay, so on this IXL assignment Z3, we're solving quadratic equations by factoring. The previous IXL, you were just solving, it was already factored for you. Now we got to factor and then we got to solve. So I'm looking at this term, it's a binomial and there's no constant term.
It is time to take attendance. Please take attendance. Thank you.
Okay, when I have a binomial like this, we can go ahead and think we can do our factors and think that we have a GCF between v squared and v. So I have a vector of v. Then when I take out the v, I'm left with a v and then a plus 50 on the inside. So now that's going to give me v is equal to 0 and negative 50. You can also look at this in Desmos. So I can do x squared and then plus 50x. I'm using x um, instead of v because it won't recognize it. So I'm looking here at my where we're crossing the x-axis. So we are crossing the x-axis here at right here's our x-axis at 0, 0. So I'm looking at my intercepts there at negative 50 and 0. So it wants you to put your solutions and separate them as commas. So that's going to be 0, comma, negative 50. And that's all we're doing here. Now we have a factored problem here. Um, we might be able to do this in Desmos. So let's see. So I'm going to do x squared, and then we're going to do plus 14x, and then I'm going to do plus 24. And I'm going to zoom in. Okay. So I've got one there at negative 2 and negative 12. So that one was easy. We can just do negative 12 and negative 2. Pretty straightforward. But I do want to show you on problems where we might have to and not be able to factor easily. So I'm going to go to a next level. Let's go up here. Okay, let's go. So let's look at this problem. So I have 3n squared minus 51 plus 48. So on this problem, I'm going to need to do my area model. And what that means is I'm going to draw my box. And I'm going to put that first term in the area for the first box. So 3n squared, and then I'm going to put 48 in the last box. We know that these two middle terms right here are going to add up to
Right.
positive 48. When the product, so 3 times 48 is positive, and the sum,
Write each solution
oops,
as an integer.
stop talking. When the sum is negative 51, so when the product 3 and 48, so 3 times 48 is going to give me 144. So this is 144. When the product is going to give me a positive number, but the sum is negative, that tells me that both of these middle terms are going to be negative. Now, I'm going to think about the factors of 144. In order to do that, I'm going to put 144, and we're going to divide this by x. Then I'm going to hit the wheel, and I'm going to convert that to a table. So I'm going to go through and I'm going to enter because 72, 48 plus 3. So 72 plus 2 is not going to give me 51. But 48 plus 3 will give me 51. Let's double check. So 48 plus 3 gives me that required 51. So I'm going to put 48 here and I'm going to put 3 there. So all I'm doing is looking at these two factors. These are the numbers that we can multiply that will give us that original product of 144. So now I just need to take the GCF between 3 and 3, which that's going to give me 3. Technically, you can pull it out either way. So this is one of those interesting ones. So I can pull out a 3 here. So 3 there, and this is going to be n. So n times n. Now, 3 divided by 48 divided by 3 is going to give me 16. and that needs to be negative 16. And then 3 divided by n is going to give me
Write
negative
each solution.
3n. Technically, that's telling me that there was probably a GCF. Let's see. 51 divided by 3. Oh, yeah, there was a GCF. So I could have pulled out a GCF. The reason I noticed that is because the 3n
Write each
minus 3.
solution as
Oh, stop. I keep hitting that. The 3n minus 3, there's a common GCF between 3n and 3. I could pull out a 3. So that lets me know that technically, so if I had the factors 3n minus 3 times n minus 16, that means I can take out another 3 between on this binomial. So this would become 3 and then n minus 1 times n minus 16. Now I have fully factored out. So that can happen if you have a situation where you end up one of the binomials has what we call a GCF. Then we could have taken out a GCF in the beginning, and that might have making our life a little bit easier. But our solutions are going to be positive 1 and positive 16. This 3 is not going to equal to 0 because there's no variable with that monomial. So our solutions are only going to be 1 and 16. I'm going to do one more. Let me go up to the next level. Okay, so in this level, we need to make sure that we are putting it and setting it equal to 0. Technically, you can use Desmos in this situation, especially thinking about test taking strategies. You can put the left side, so 33, we're going to do x squared, and then I'm going to put 32x. I'm going to use x instead of um, oops. If you notice, so we're intersecting there at 0, and then there's going to be one more intersection, or they might be. Hold on. Yeah, it's going to intersect right about somewhere over there. It's kind of hard to see. Oh, there it is. Come on, go. Hold on. Did I not? Oh, I deleted it. Shoot. I deleted the 33. Why? Screw it. All right, let's just do it the other way because this problem's easy anyways. So I just need to move the 32 over. So this becomes 33y squared minus 32y equals 0.
write each solution as
So
an in.
I have a GCF of y, and then I'm going to look for a GCF between 33 and 32. So I'm going to type GCF parentheses, and I'm going to put 33 comma 32. There is no GCF between those two. So I have a GCF of y. That gives me 33y minus 32 equals 0. So now that means that my solution is going to be y equals 0. And remember that number here goes on top. So that's 32 over 33. 32 divided by 33 is not going to simplify. So that's 0, comma, 32, sorry, divided by 33. That is your answer choice. Again, I'm going to move this 13j over. So this becomes 5j squared minus 13j plus 8 equals 0. So I made sure to put it in standard form. I'm going to go ahead and factor this like we did the other one. So I'm going to put 5j here in the middle. We're going to put positive 8 there. Oh my God. Y'all are killing me. Lord. Okay, sorry about that. All right, 5 times 8 is going to give me 40. Okay, I guess we're done now. All right, hopefully we're done. So I'm going to look at the factors of 40. Again, we know both of these are going to be negative. So because the product is positive. So the factors of 40 that are going to add up to 13. So I'm going to do 40 divided by x, convert to a table. And again, we are adding the two terms together. 10 plus 4 is going to give me 14. 8 plus 5, 8, 9, 10, 11, 12, 13, 8, and 5. That's exactly what we want to use. It really doesn't matter which order you put these in. Since this is 5 and this is 5, this is going to be 5 up top. 5J there. J is going to be there. That's going to be minus 8 on that side because that's, yep, 5 divided by 5 is going to be negative 1. So that tells me my factors are going to be 5j minus 8 and j minus 1. So that means my solutions are going to be 8 divided by 5, comma, and positive 1. And we're done. All right. Hopefully that at least gave you a good start on that and working out those problems on that. I will see you next time.